Assalamualaikum and good evening, everybody. My name is Muhammad Denis bin Noranis, and my team will present about the portal camping machine. Next slide. For the list of the content is introduction, problem statement, circuit design, component explanation, circuit explanation, costing, and conclusion. And for the introduction, this project is involving designing and implanting a control circuit to automate the operation of a double-acting pneumatic cylinder into the bottle capping machine. The circuit integrates electrical and pneumatic components to ensure precise sequential movement, making it highly relevant for industrial automation applications that demand preventive and reliable bidirectional motion. This system is ideal for bottle capping tasks where automated bidirectional and repetitive motion is essential for efficient and consistent cap placement. And for the next slide is bottle capping machines are widely used in various industries because they are essential for any process requiring safe and secure sealing of bottle product. For example, this machine is used in food and beverage industry, pharmacy industry, domestic and personal care industry, chemical industry, and oil and lubricant industry. For the next slide is why use bottle capping machine? Because it is efficiency, increase production speed compared to manual capping, and it is consistency ensure a uniform and secure seal across all bottles. And it is hygiene. It reduces human contact, maintaining cleanliness and product integrity. Why is this is a must? Because hygiene in a cosmetic industry is a very must because of we need a cleanness and product integrity. And for the last is scalability, suitable for small scale to large scale production environments. That's all from me. Next is my friend will state about problem statement.
Thank you. So my part is problem statement. So for the problem statement is about description of the process. We explain. The first is when a bottle is placed under the capping head, the machine initiates the capping process by screwing the bottle in position. So the first step in the process is securing the bottle in place. This involves using clamps, grips, or a positioning mechanism to hold the bottle steady. By doing so, the bottle is prevented from moving or tipping over during the subsequent steps, ensuring that the cap can be applied accurately and securely. This precise positioning is critical for achieving a consistent seal and maintaining the quality of the capping process. So the second is a push button actuator or automatic sensor trigger the capping mechanism which lower the capping head onto the bottle. So the push button actuator is if a push button is used and operator manual presses the button to activate the capping mechanism. The provides control over when the process starts. So for the automatic sensor, in automatic system, the sensor detect the presence of the bottle under the capping head. They eliminates the need for manual input as the machine automatically trigger the mechanism upon detection. And the third is the cap is tightened using rotational force, ensuring it is securely sealed onto the bottle. So for the third one is once the clipping head is properly positioned on the bottle, the machine applies rotational force to tighten the cap. This rotation this rotational movement is typically driven by motors or pneumatic system within the capping mechanism. So if you put the little force, the cap may not seal correctly, leading the potential leaks or contamination. And if you push too much force, the cap or bottle may become damaged, compromising the integrity of the product. So by carefully controlling the rotational force, the machine ensures the cap is both secure and undamaged, meeting quality and safety standards. So the last one is, once the cap is properly applied, the capping head retract, release the seal bottle. So for the last one is, after the cap has been securely tightened onto the bottle, the capping head automatically retracts. This upward movement disengage the capping head from the seal bottle. Once retrieved, the bottle is no longer held in position and released from the machine grips. The seal, the seal bottle is then ready to be moved along the production line for further processing, such as labeling, packaging, or quality inspection. This final step ensures a smooth transition to the next of the manufacturing process while maintaining efficiency and consistency. So for the parameter, the first one is use an automate or semi-automate capping mechanism. Next, the machine should be able to handle various cap and bottle size, and pneumatic or motorized components can drive the capping process for speed and efficiency. The last one is ensure the system can be operated manually or integrate with a production line. So here's the warning. This bottle capping machine improve efficiency, reduce human error, and ensure consistent sealing, making it ideal for small to medium scale production lines. Let me know if you need a more detailed. So, my next plan will explain the circuit design.
Hello, Assalamualaikum. My name is Haikal. Thank you to Lokman. My part is circuit design. I will show the circuit in this slide. Okay, continue. My part is component explanation. I will discuss about component that we use in the circuit. Okay, first, pneumatic components. We use 5 two-way solenoid valve. This valve controls the flow of compressed air to different parts of the circuit. The image shows two of this valve likely used to control the movement of the double-acting cylinders. For the 5 two-way solenoid valve, the 5 two-way solenoid valve function for valve are like switch that controls the flow of compressed air. They have two positions, 5 and 2 stable state 2. For the operation of 5 two-way solenoid valve is when the solenoid coil is energized with an electrical signal. The valve shift its position, allowing or blocking the flow of air. Okay, the second for pneumatic components is a double-acting cylinder. The cylinder can extend and retract using compressed air. The circuit appears to have two of these cylinders, likely used for the capping and decapping operation. Okay. Double-acting cylinder function is cylinders are actuators that convert compressed air energy into linear motion. For the operation for double-acting cylinder is they have two parts. One for each side of the piston. When air is supplied to one port, the piston moves in that direction. To reverse the direction, air is supplied to opposite port. Okay, the third for the pneumatic component is a compressed air supply. This, this is the source of compressed air for the entire system. Okay, for the function compressed air supply, this is the source of compressed air for the entire pneumatic system. For the operation, is compressed air is typically generated by an air compressor and stored in a reservoir tank. It is then distributed through the system to power the various pneumatic components. Okay, next, for the electrical components, we can see four components for electrical components. First, electrical connection OV. Electrical connection OV is a provide a ground of common connection for the electrical signals. For the function of electrical connection OV is this is the reference point or ground for the electrical circuit. It ensures that there is a common reference point for all the electrical signals. Second, for electrical component is electrical connection 24 volt. Supplies the power for the solenoid valve. For the function of electrical connection 24 volt is this supplies the power needed to energize the solenoid coils within the 5 two-way solenoid valve. In the role in the circuit, it provides the necessary voltage to activate the valve and control the flow of compressed air. For the third, uh, is make switch. These switch are used to manually activate the circuit. For the function of make switch, these are manually switch that can be used to turn the circuit on off. Role in the circuit, they allow for manual control of the system, bypassing the automatic control if needed. For the last of electrical component is valve solenoids. These are the coils within the solenoid valve that, when energized, shift the valve spool to control the airflow. For the function of valve solenoid is these are the electromagnetic coils within the solenoid valve. For the operation of valve solenoids, we can see that when an electrical current is passed through the coil, it generates a magnetic field that attracts a movable core. This movement shifts the valve spool, controlling the flow of air. For the role in the circuit, they are the way component that convert electrical signals to mechanical action, allowing the 5 two-way valve to control the flow of compressed air. For the lastly, I want to explain about how they work together for the electrical component. Power is supplied to the circuit from the 24 volt connection. Then the make switch is closed, completing the circuit. After that, electrical current flows through the valve solenoid coils. Okay. And next, the solenoid coils generate magnetic fields, shifting the value spools. And then lastly, the valve spools control the flow of compressed air to the double acting cylinders. Okay, thank you. That's it for me. Next, we give to Acha.
My name is Ashraf Daniel, and I will explain about the circuit explanation. Which is the first one is pneumatic circuit diagram. First is solenoid valve. These valves are control the flow of compressed air to the cylinders. Secondly, the cylinders. These cylinders are likely responsible for various motions within the capping machine, such as filling the bottle, aligning the cap, and applying torque to the cap. And third, limit switches, not explicitly labeled. These switches detect the position of the cylinders and send signals to the control systems. And for the second one, the electro-pneumatic circuit diagram. First, the power supply, which is 24 volt and OV. which is provide the necessary voltage for the electronic components. Second, input signals. These signals likely comes from the sensor or control systems and trigger the capping sequence. Third, logic gates. These gates combine the input signal and the other signals to control the solenoid valve. Fourth, solenoid valve drivers. These components convert the electrical signals from the logic gates into signals that can control the solenoid valve. And third, which is the sequence of operation. Firstly, the input signal. The input signal is activated, indicating the start of the tapping process. Second, logic gates. The logic gates process the input signals and generate appropriate output signals to control the solenoid valve. Third, solenoid valve. The solenoid valve receives the signals and either open or close, allowing or blocking the flow of compressed air to cylinders. Fourth, cylinder movement. The cylinders, driven by the compressed air, execute their respective motions. This might include gripping the bottom, aligning the cap, and applying torque to the cap. Fifth, limit switches. As the cylinders reach their end position, the limit switches send signals back to the input system, indicating completion of the specific motion. And lastly, cycle repeats. The cycle repeats as long as the input signal is maintained. And I will explain more about the application of the circuit. The system is well suited for process that require sequential motion of actuators. Some examples include assembly line automation used for pick and place mechanisms, sequential pressing or stamping in manufacturing, and second, bottle capping machines. In a bottle cap applications, one cylinder might move to the bottle into positions while the other applies the cap, which is what currently we are talking about. And third, packaging machines can handle sequential packaging steps like positioning and sealing. Fourth, material handling, automated systems to push, pull, or hold components in a specific sequence. Fifth, clamping and pressing machines, used in tasks where materials need to be held steady and worked on. For example, welding or machining. And next, I will give it to Sean.
Okay, thank you, Muhammad Ashraf. And I will explain about costing. Because every component do have a value, right? So pneumatic bottle cap components, firstly is push button. It will cost 5 to 10 ringgit, depends on type of brand. I'm searching for this component through a Shopee and another web like a Lazada and so on. And for the second component is 5 per 2-way solenoid valve, which is we need 2 units of it. It costs RM 30 ringgit to 45 per unit. So total we need is 120 to 200. Depends on the brand and type of it. And for the third one is flow control valve. We do need 2 units too. And for the cost, we will need 120 ringgit per unit. Total we will spend 240. And the four component is airline fitting. We need 6 units. It will cost 50 ringgit to 20 per unit. And it will cost a RM 30 to 40. And for the 5 component, we will spend around 100 to 200, which is double acting cylinder. We need 2 units of it. This is varies based on size and stroke of the line. And for the 6 component, a compressor, 1 unit. It will cost us RM 300 per unit. This is the most expensive component in this bottle capping machine. And for the 7 is the frame and housing, 1 unit, costs around RM 50 per unit. And for the 8 component is mounting hardware, bracket, screw, and etc. It will cost around 20 to 30 ringgit. And for the 9 component is make switch, RM 100 to 200. And for the 10 component is wire connection, RM 20 to 30. And total estimate cost is 1,000 without compressor or 1300 with compressor. That's all about costing. And for the conclusion for pneumatic bottle capping machine is the pneumatic bottle capping machine represent a significant advancement in the automation of bottling processes, offering enhanced efficiency, precision, and reliability by utilizing compressed air to drive the capping machine mechanism. This machine reduce the need for manual labor and ensure consistent capping performance across a wide range of bottle size and cap types. The machine key benefit include a quick adjustment to different bottle formats, high speed operation, and minimal maintenance requirement. Additionally, its capacity for continuous operation and the reduction in operative fatigue contribute to overall production cost saving. In conclusion, the pneumatic bottle capping machine is a vital component in modern manufacturing lines, providing manufacturers with a reliable and cost-effective solutions for high-volume production. It is easy to use, adaptability and durability make it an essential tool for industry, such as food and beverage, pharmacy, and cosmetic, helping to improve product quality, extends operational efficiency, and ensure packaging consistency. That's all. Thank you. This is our team presentation. That's all. Thank you.